Hello friends, welcome to ElectrAspirant, an assistance to electrical students for objective type exam preparation. So this is an initiative from the Department of Electrical and Electronics Engineering of Christ College of Engineering in Inyalakuda. So in this video, we are going to discuss about the questions from 51 to 75 of Assistant Electrical Inspector exam to Kerala Electrical Inspectorate conducted by the Kerala PSC in the year 2014. So we can expect this exam in the nearby future. The Kerala PSC will conduct the Electrical Inspectorate exam in the nearby future as well. So we are starting with the question 51. So what is the penalty factor of a plant if its incremental loss is 0.2? We know the equation for penalty factor is 1 by 1 minus loss. So here the loss is 0.2. So 1 by 1 minus 0.2. We will get it as 1.25. So the answer is option D, that is 1.25. And the next one is, what is the new steady state frequency if a 10 megawatt load increase occurs in an area with frequency 50 Hz, governor regulation R is equal to 0.1 per unit, and frequency dependent component of load change D is equal to 0.8 per unit on 100 MVA base. So we have to find the new steady state frequency here, and we know the equation of the new steady state frequency is equal to delta F. Delta F is equal to minus 1 by D plus 1 by R into delta P. Okay, so here the delta P is the change in load, and delta F is the change in frequency, and D and R is already given. Okay, so we are going to substitute the values here. So here the delta F, okay, delta F by 50 is the original frequency. Okay, normally working frequency 50. So we have to express delta F in terms of 50 here, normal frequency. So minus 1 by 0.8 plus 1 by 0.1 into delta P is expressed as 10 megawatt is the change in load, 10 by 100 MVA, that is 100. Okay, so from that we will obtain delta F as minus 0.46296. Okay, and we have to find the new frequency. New frequency F will be 50 minus the delta F we got. Okay, 50 minus 0.46296. So the answer is 49.537 Hz. Okay, so here the option B is correct, that is 49.537. so the option B is correct. And next one is, a circuit breaker is connected to a 132 kilovolt bus bar. What is the maximum value of restriking voltage across the contacts of the circuit breaker? So this question is cancelled by PSC in its final answer key. And the next one is, the current chopping occurs during. So the correct answer, we know a current chopping is a phenomenon in which the current is forcibly interrupted before the natural current is making to zero. Okay, that is, the current chopping normally occurs when small inductive current are disconnected from load. So here the option C, that is disconnection of transformer on no load. So it is a small inductive current load. So option C is correct. Option C. And the next one is, a 400 kV surge travels on an overhead line of surge impedance 400 ohm towards its junction with a cable which has a surge impedance of 40 ohm. What is the transmitted voltage? So the equation for the transmitted voltage here is, the equation for transmitted voltage is E is equal to 1 plus Z2 minus Z1 by Z2 plus Z1 into E dash. So here the Z2 value is the surge impedance of cable, and Z1 will be the surge impedance of line, and E dash will be the incident voltage wave. And these three values are given in our question, so we are substituting the values here. So 1 plus surge impedance of cable is given as 40, so 40 minus surge impedance of line is 400 by 40 plus 400 into 400 kV. Okay, so we will get the answer as 72.727 kV. So here the option B, 72.73. okay, so it is correct. Okay, option B is correct. And the next question is, which of the following is an example of high frequency electric heating? So the correct answer is induction furnace, option B. Option B, induction furnace. The correct induction furnace is used high frequency heating. It is mainly used for melting the metals like scraps, etc. And the next question is, an illumination on the working plane of 32 lux is required in a room 80 meter by 15 meter, assuming a utilization factor of 0.5, lamp efficacy of 14 lumen per watt, and a candle power depreciation of 0.2. Estimate the number of 200 watt lamps required. So we have to calculate the number of 200 watt lamps required in a room. Okay. So before that, we have to first calculate total area. Total area is 80 meter into 15 meter. We will get the total area, and also the total lumen required. Total lumen required will be getting by multiplying this 32 lux by the area. Okay. So we are moving to the calculations here. So the area is equal to 80 into 15, that is 1200 meter square, and the total lumen required. Okay, lumen required will be, it is equal to area into the lux. Okay, that is 32 into 1200, it is equal to 38,400 lumens. It is the total lumen required, but the total lumens to be given out by the lamps. Okay, total lumens to be given out by the lamps will be equal to total lumen required divided by utilization factor into MF. Okay, that is lumen required divided by UF into MF. Okay, that is the UF into utilization factor is given, and MF means the maintenance factor. Maintenance factor is 1 minus the depreciation. Okay, the candle power depreciation. Okay, so here lumen required is 38,400 by UF is 0.5 into MF. You will get it as 1 minus 0.2, you will get as 0.8. Okay, so the answer is 96,000. This is the total lumens to be given out by the lamps. Okay, and for calculating the total wattage, okay, total wattage will be, okay, total wattage of the lamps required will be, okay, total lumens given out by the lamp, that is 96,000 divided by efficiency of each lamp, that is 14 lumen. Okay, 14 lumen per lamp, it is already given in the question here. Okay, so that we will get it as 6857 Okay, 68.174. And number of 200 watt lamps required will be, okay, we have to divide this value. Okay, we have to divide this value by 200. We will get it as 34.28. So in the question, the option 36, we can select the option 36, which is near 34.28. So 36 is the correct answer. And the next one is the specified parameters for a slack bus in load flow analysis are. And here for a slack bus, the known values are the voltage, magnitude and phase angle. Okay, and for load bus, the known values will be active and reactive power, that is P and Q. And for generator bus, the known values will be active power and voltage, magnitude, okay, P and V. And the next question is, which of the following is true for a suburban electric traction service? Okay, so the correct answer here is option A, costing period is longer. Okay, free running period will not be there in suburban service. The free running period will be there only in mainline service. Okay, and the next question is, the dead weight of an electric train is 200 tons. The distance between station is 1.6 kilometers and there is a uniform gradient of 1 in 80 between the stations. The tractive effort due to gradient is, okay, so this can be find out using the equation. The tractive effort equation will be equal to 10 into Wg. Okay, Wg is the weight of the train, it is given as 200 tons, and G is the gradient is also given 1 by 80. So you will get it as the answer, you will get as 2500 kg. So the option B is correct, 2500 kg is correct. Next one is, for a given scheduled speed, the specific energy consumption for an electric train is. So here the option A is correct, larger for suburban service, that is compared to mainline service, the energy consumption is larger for suburban service. And the next question is, which of the following material is used as a moderator in nuclear reactors? So in nuclear reactors we are using graphite as the moderator, so option D is correct. And next one is, chalk is provided in a fluorescent lamp too. Option C is correct, that is chalk is used to provide stability to the arc in the tube. And the next question is, which of the following use a resonant converter for its operation? So this question is also cancelled by the PSC in its final answer key. The next one is, what will happen if the field of a DC motor opened while running? Okay, so we know that the speed of a DC motor, the equation regarding that is N directly proportional to EB by 5. So here, when the field is open means the flux reduces to 0. When the flux reduces to 0, the speed will dangerously increase. So the option B is correct, that is motor will attain dangerously high speed. Next one is, which of the following motors has highest no load speed? So the option A is correct, that is series motor will have highest no load speed. Okay, and the next question is, the resistance of a moving coil instrument is 10 ohm, which gives full scale deflection when carrying a current of 50 milliampere. What should be the value of shunt to be connected to extend its range to 100 ampere? So the equation for shunt resistance is RSH will be equal to R instrument resistance divided by N minus 1. Okay, so here the value of N, we have to calculate the value of N is equal to, okay, new range of the meter divided by full scale deflection. Okay, so here the new range of the meter is 100 ampere and the full scale deflection is 50 milliampere. Okay, so I will get as 100 by 50 milliampere, 50 into 10 raised to minus 3 ampere. Okay, so I will get it as N as 2000 and we will substitute here, that is R instrument is 10, so 10 by 2000 minus 1, that is 1099. Okay, so here we will get it as RSHS as 0.005. Okay, so here the option D is correct. 0.005 is correct. And next question is, what will be the load power factor if one wattmeter read positive and the other 0? Yes, this question is also cancelled by the PS in the final answer key. Next question, a dynamometer moving coil instrument can measure, option C is correct, that is both AC and DC, but a PMMC meter can measure only the DC values. Okay, you have to remember that. Next one is, which of the following bridge rectifiers has highest harmonic content in output voltage? Highest harmonic content will be for single phase half wave rectifier. And the next question is, the rotor copper loss for a 4-pole 3-phase 50 Hz induction motor running at 1495 rpm is 50 watt. Its rotor input is, so we know a relation, that is rotor input. Okay, rotor input is to copper loss is to mechanical power output. Okay, it's equal to 1 is to S is to 1 minus S. Okay, so here S is a slip. Okay, so by calculating slip, S is equal to, you know that, Ns minus Nr by Ns. Okay, so here it is a 4-pole. Okay, 4-pole 50 Hz machine. So using the equation 120 F by P, we will get as Ns as 1500 minus Nr is 1495 by 1500. So the value of slip, we will get it as 5 by 1500 is equal to 1 by 300. So slip will be 1 by 300. Okay, and for using this relation, the rotor input value, okay, the rotor input value will be is equal to the copper loss divided by the slip. Okay, so copper loss is 50 watt, 50 by 1 by 300, we will get it as, okay, kilowatt. So the option B is correct, Sandion B. And the next question is, the electrical representation of a variable mechanical load of a 3-phase induction motor is the resistance given by, option D is correct, R2 into 1 by S minus 1. That is, normally we are writing R2 into 1 minus S by S, which means R2 into 1 by S minus 1. So here option D is correct. If V is the next question is, if V is the voltage applied to the stator of an induction motor, the electric torque T is proportional to the option C, that is torque will be proportional to V square. Next one is, the rotor slots of squirrel cage induction motor are given as lights Q in order to reduce magnetic hum, that is option B is correct. And next one is, the speed of a 3-phase 4-pole 40 volt 50 Hz induction motor is 1440 rpm. What is the frequency of rotor EMF? The frequency of rotor EMF is equal to SF. So here the slip S is equal to, we will know that it is a 3-phase 4-pole 50 Hz machine. So the synchronous speed will be 1500 minus 1440 by 1500. So you get 60 by 1500 is equal to 0.04. Okay. So S into F, that is 0.04 into 50, we will get as 2 Hz. So the option C is correct, that is option C, 2 Hz. Okay, I hope all of you understand the questions well. Thank you very much.